Hello friends, today we will see practice problems on matrices and determinants. This is third video on the chapter matrices. In this video we will see specifically problems on operation on elementary operations of a matrix as well as few introductory problems to determinants. Problems based on elementary operations of a matrix. Using elementary transformations, find the inverse of each of the matrices if it exists 2, 1, 1 and 0. Now, let A is equal to the given matrix, that is 2, 1, 1 and 0. Now, in order to use the elementary operations, we should write A is equal to I into A, where I is equal to identity matrix. Now, as A is having order 2 by 2, I should also be identity matrix of order 2 by 2, and we will reach to the step of I is equal to A inverse into A, that is 2, 1, 1, 0 is equal to 1, 0, 0, 1 into A. 1, 0, 0, 1 is nothing but identity matrix of order 2. Now in order to bring 1 in the place of this 2, what we should do, first elementary operation as R1 is equal to R1 minus R2. So, if we subtract 1 from 2, then we would get 1, that is first row first element should be 1. Now, this 2 minus 1 is equal to 1 and this 1 minus 0 is equal to 0. So, first row will become 1 0, second row 1 1 as it is. Now, the same operation will be repeated to the right hand side. So, first row first column will be 1 minus 0 is equal to 1, and first row second column will be 0 minus 1, that is minus 1, and second row as it is, that is 0 1 into A. In the first row we have already obtained 1 and 0, and second row of this matrix is second row of the matrix on the left hand side is 1 1, but we want it to be 0 and 1. So, what we will do is we will subtract R1 from R2, so that we will get 1 in the second row first column. So, R2 will become now R2 minus R1. So, 1 0 as it is. Now, second row first column is 1 minus 1, that is 0, and second row second column is 1 minus 0 is equal to 1. Similar operations we will repeat on right hand side. 1 minus 1 first row as it is. In the second row 0 minus 1 will be equal to minus 1, and 1 minus minus 1 is equal to 2. So, we have got, now on the left hand side we have already obtained identity matrix, that is 1 0 0 1 is equal to 1 minus 1 minus 1 2 into A. So, this is in the form of I is equal to A inverse into A, and hence we can say that A inverse is equal to 1 minus 1 minus 1 into 2. You can easily cross verify your answer by the multiplication of A into A inverse, and it should be nothing but I. Moving to next problem. Using elementary transformation, find the inverse of each of the matrices if it exists 1, 3, 2 and 7. Now, similar to previous problem, let A is equal to 1, 3, 2 and 7. Again, in order to use elementary operations, we would write A is equal to IA, and we should reach up to I is equal to A inverse into A. So, we will start with our first step. 1 3 2 7 is equal to 1 0 0 1 into A. Now, first row first column element is 1, which is in the required format. Now, we will move to second row first column. In the second row first column, right now there is element 2, and we would want it to transform it to 0. So, what we should do is we will multiply the first row by 2, and then we will subtract that row from R2. So, R2 will become R2 minus twice of R1. First row as it is 1, 3. Now 2 minus 2 into 1 is equal to 0. Similarly, 7 minus 2 into 3, that is 7 minus 6 is equal to 1. On the right hand side, first row as it is 1, 0, and for the second row, first column, 0 minus minus 2 is equal to minus 2, and 1 minus 2 into 0 is equal to 1. So in this step we have got 1, 3, 0, 1 is equal to 1, 0 minus 2, 1 into A. Now we have already got first column in the required format, that is 1 and 0. Now we will move to first row, second column. So first row, second column element should be 0. So here what we should do is, if we multiply second row by 3 and if we subtract that row from R1, then we should get the required element. So R1 should be equal to R1 minus thrice of R2. Now 1 minus thrice of 0 is 1 as it is. Then 3 minus 3 into 1 is equal to 0. Second row is 0, 1 as it is. Now on the right hand side, 1 minus minus 3 into minus 2, that is 1 plus 6 is equal to 7, and 0 minus 3 into 1 is equal to minus 3. Hence first row is 7 and minus 3, second row minus 2, 1 as it is. So here on the left hand side we have obtained identity matrix of order 2, that is 1, 0, 0 and 1, and it is in the form of I is equal to A inverse into A, and hence A inverse is equal to 7 minus 3 minus 2 and 1. Moving to next problem. Now we will find out inverse matrix for 3 by 3 order. Using elementary transformation, find the inverse of each of the matrices if it exists: 2, 0, minus 1, 5, 1, 0, 0, 1 and 3. Now similar to previous problem, let A is equal to 2, 0, minus 1, that is given matrix 2, 0, minus 1, 5, 1, 0 and 0, 1 and 3. So we should start from A is equal to IA, and we will reach up to this step of I is equal to A inverse into A. Now here given matrix A is of the order 3 by 3. So the identity matrix which we would be taking into consideration, that should also have an order of 3 by 3. Hence we will write 2, 0, minus 1, 5, 1, 0, 0, 1, 3 is equal to 1, 0, 0, 0, 1, 0 and 0, 0, 1 into A. Now as of now, first row, first column element is equal to 2. So if we divide this first row by 2, that is if we multiply the first row by 1 by 2, we would get 1 in place of 2. Hence R1 will become 1 by 2 into R1, that is 2 divided by 2 is equal to 1, 0 divided by 2, 0 and minus 1 divided by 2 is minus 1 by 2. R2 and R3 will remain same, 5, 1, 0, 0, 1, 3 is equal to. Now again 1 divided by 2 is 1 by 2, 0, 0 as it is, 0, 1, 0, 0, 0, 1, that is R2 and R3 will become as it is into A. Now if you observe second row, so second row first column is equal to 5. Now here what we want is it should be 0. So if I multiply row 1 by 5 and subtract it from R2, I should get 0. So R1 as it is 1, 0 minus 1 by 2. Then R2 will be revised as R2 minus 5 into R1. So 5 minus 5 into 1, that is equal to 0. 1 minus 5 into 0 is equal to 1. And 0 minus 5 into minus 1 by 2 will become plus 1 by 2. So second row is equal to now 0, 1 and 5 by 2. Third row as it is, that is 0, 1 and 3 is equal to 1 by 2, 0, 0. Now 0 minus 5 into 1 by 2, that is minus 5 by 2. 1 minus 5 into 0 as it is. 0 minus 5 into 0 is 0. And third row 0, 0, 1 as it is. Now in row R3, second column element is equal to 1, which should be equal to 0. So simply if we subtract R2 from R3, we should get 0 in place of 1. So R3 will become R3 minus R2, that is 1, 0 minus 1 by 2, 0, 1, 5 by 2. Now 0 minus 0 is equal to 0, 1 minus 1 is equal to 0 and 3 minus 5 by 2 is equal to 1 by 2. On the right hand side, 1 by 2, 0, 0 as it is. Second row is minus 5 by 2, 1 and 0 is also as it is. And in the third row, first column, 0 minus minus 5 by 2 will become plus 5 by 2. 0 minus 1 is equal to minus 1 and 1 minus 0 is equal to 1. Now coming back to first row, in the first row we have already got 1 and 0, but first row column 3 element is minus 1 by 2, which should be equal to plus 1 by 2. So simply what we will do is we will add R1 and R3. So R1 will become R1 plus R3. Now 1 plus 0 is 1, 0 plus 0 is 0 and minus 1 by 2 plus 1 by 2 is equal to 0. Row 2 and row 3 as it is, that is 0, 1, 5 by 2 and 0, 0, 1 by 2 is equal to, now 1 by 2 plus 5 by 2 will become 6 by 2, that is nothing but 3. 0 minus 1 is equal to minus 1 and 0 plus 1 is equal to 1. R2 and R3 as it is, that is minus 5 by 2, 1 and 0, 5 by 2 minus 1 and 1. Now in the second row, instead of 5 by 2 there should be 0. So we will revise R2 as R2 minus 5 into R3. Now first row as it is, that is 1, 0, 0. So 0 minus 5 into 0 as it is, 1 minus 5 into 0 again as it is, 5 by 2 minus 5 into 1 by 2 is equal to 0. Third row as it is, that is 0, 0 and 1 by 2. On the right hand side, 3 minus 1 and 1 as it is. Now minus 5 by 2 minus 5 into 5 by 2 will become minus 15. 1 minus 5 into minus 1 will become 1 plus 5, that is 6, and 0 minus 1 into 5 is equal to minus 5, and third row as it is, that is 5 by 2 minus 1 and 1. If you observe row 3, that is 0, 0 and 1 by 2, which should be equal to 0, 0 and 1. So we will simply multiply R3 by 2, that is 1, 0, 0, 0, 1, 0 and 0, 0, 1 is equal to minus 3 minus 1, 1, minus 15, 6 and minus 5, 5, minus 2 and 2. Now on the left hand side, if you observe, this is nothing but identity matrix of order 3, that is 1, 0, 0, 0, 1, 0 and 0, 0, 1. So it is in the required format of I is equal to A inverse into A, and hence A inverse is equal to 3 minus 1, 1, minus 15, 6 and minus 5, 5 minus 2 and 2. Now we will see few problems based on the introduction of determinants. Evaluate delta is equal to 2, 3 minus 2, 1, 2, 3 and minus 2, 1 and minus 3 by expanding it along with the second row. Now here in the question what they have asked us is we need to expand this matrix along with the second row. So let us suppose delta is equal to 2, 3 minus 2, 1, 2 and 3 minus 2, 1 and minus 3. Now we want to expand this along with second row. So we should write first element as minus 1 raised to I plus j, that is minus 1 raised to 2 plus 1, because we are expanding it along with this second row. So element 1 is second row first element, hence I is equal to 2 and j is equal to 1, hence minus 1 raised to 2 plus 1 into 1. Now the remaining matrix for this 1 is equal to this 3 by 2 and this 1 minus 3. So first term will become minus 1 raised to 2 plus 1 into 1 into determinant 3 minus 2, 1 and minus 3 plus minus 1 raised to 2 by 2. Now for this 2, I is equal to 2 and j is also equal to 2. Hence minus 1 raised to 2 plus 2 into 2 and into determinant 2 minus 2 minus 2 and minus 3 plus, now for this 3 I is equal to 2 and j is equal to 3. So plus minus 1 raised to 2 by 3 into determinant 2, 3 minus 2 and 1. Now minus 1 raised to 2 plus 3 is equal to minus 1. So minus 1 into 1 is nothing but minus 1 into determinant 3 minus 2, 1 and minus 3 plus minus 1 raised to 2 plus 2 is equal to plus 1. So plus 1 into plus 2 is plus 2 into determinant as it is, that is 2 minus 2 minus 2 and 3 plus minus 1 raised to 2 plus 3 is equal to minus 1. Hence minus 1 into plus 3 is equal to minus 3 into determinant 2, 3 minus 2 and 1 as it is. Now we will solve these determinants, that is minus 1 into, now this 3 into minus 3 is equal to minus 9 minus 2 into 1 is equal to, hence it should be minus 9 plus 2, that is minus 7. So minus 1 into bracket minus 9 plus 2 plus 2 into bracket 2 into minus 3 is minus 6 minus 2 into minus 2 is equal to minus 4 plus minus 3 into bracket 2 into 1 is plus 2 minus 3 into minus 2 is plus 6. Hence it is minus 2 plus 2 minus 9 plus 2 is equal to minus 7, but minus 7 into minus 1 is equal to plus 7 plus 2 into bracket minus 10, that is minus 20 minus 3 into bracket 8 is equal to minus 24. Hence 7 minus 20 minus 24 is equal to minus 37. So answer to this determinant, that is 2, 3 minus 2, 1, 2, 3 and minus 2, 1 minus 3 is equal to minus 37. Moving to next problem, determine the value of x for which the matrix A is equal to x plus 1 minus 3, 4 minus 5 x plus 2 and 2 and 4, 1 and x minus 6 is singular. Now, if the determinant of the any particular matrix is 0, then we call that matrix as singular matrix. So, first of all, we will calculate the value of the given determinant, that is, let us suppose it is delta. Now, it is already given that this matrix is singular, and when the matrix is singular, for that singular matrix we need to calculate the value of x. Hence, it is already given that this delta is equal to 0. Hence we will write our first step as delta is equal to x plus 1 minus 3 4 minus 5 x plus 2 2 and 4 1 x minus 6 is equal to 0. Now we will expand this matrix along with the first row. So for the first row, first element I is equal to 1 and j is also equal to 1. So minus 1 raised to 1 plus 1 into x plus 1 into determinant x plus 2 2 1 and x minus 6 plus. Now for minus 3 I is 1 and j is plus 2. So I is equal to minus 1 raised to 1 plus 2 into minus 3 into determinant minus 5 2 4 and x minus 6 plus first row third column element is 4, hence minus 1 raised to 1 plus 3 into 4 into determinant minus 5 x plus 2 4 and 1 is equal to 0. Now minus 1 raised to 1 plus 1 is equal to plus 1, hence we will write x plus 1 into determinant x plus 2 2 1 x minus 6. Now minus 1 raised to 1 plus 2 is equal to minus 1. Minus 1 into minus 3 will become plus 3. So plus 3 into determinant minus 5 2 4 and x minus 6 and minus 1 raised to 1 plus 3 into 4 is plus 4, hence 4 into minus 5 x plus 2 4 and 1 is equal to 0. Now we will expand this determinant. So x plus 1 into bracket x plus 2 into x minus 6 minus 2 plus 3 into bracket minus 5 into bracket x minus 6 minus 4 into 2 is 8 plus 4 into bracket minus 5 into 1 is equal to minus 5 minus 4 into bracket x plus 2 is equal to 0. Hence x plus 1 into bracket x square minus 4x minus 12 minus 2 plus 3 into bracket minus 5x plus 30 minus 8 plus 4 into bracket minus 5 minus 4x minus 8 is equal to 0. Hence we can further simplify as x plus 1 into bracket x square minus 4x minus 14 plus 3 into bracket minus 5x plus 22 plus 4 into bracket minus 4x minus 13 is equal to 0. Now if we further simplify up to cubic polynomial, then it will become, the expression will become x3 minus 4x square minus 14x plus x square minus 4x minus 14 minus 15x plus 66 minus 16x minus 52 is equal to 0. Hence it is x cube minus 3x square minus 49x is equal to 0. Now we can take x common from left hand side. So x into bracket x square minus 3x minus 49 is equal to 0. So now either x is equal to 0 or we can say as x square minus 3x minus 49 is equal to 0. So we will further try to factorize x square minus 3x minus 49 is equal to 0, but we cannot find required factors of 49 which can give summation as minus 3. Hence we will find out the value of x by formula. What is the formula to find out the value of x? That is x is equal to minus b plus or minus b square minus 4ac upon 2a, where a is equal to 1, b is equal to minus 3 and c is equal to minus 49. Hence x is equal to minus into minus 3 plus or minus under root minus 3 bracket square minus 4 into minus 49 upon 2 into 1. So we get x as 3 plus or minus 9 plus 196 upon 2, that is x is equal to 3 plus or minus under root 205 upon 2. So we can say that there are 3 possible values of x, that is 0, 3 plus root 205 upon 2 or 3 minus root 205 upon 2. Evaluate delta is equal to 1 sin theta 1 minus sin theta 1 sin theta minus 1 minus sin theta and 1. This determinant you need to evaluate and also prove that 2 is less than equal to delta less than equal to 4. That means initially we need to find out the value of delta and we also need to prove that this value lies in between 2 and 4. Delta is equal to 1 sin theta 1 minus sin theta 1 sin theta minus 1 minus sin theta and 1. Now, we will expand this determinant along with row 1. So, minus 1 raised to 1 plus 1 into 1 into determinant 1 sin theta minus sin theta 1 plus, for the first row second element, minus 1 raised to 1 plus 2 into sin theta into determinant minus sin theta minus 1 and plus 1 plus minus 1 raised to 1 plus 3 into 1 into determinant minus sin theta 1 minus 1 and minus sin theta. Now, we will expand this expression. Minus 1 raised to 1 plus 1 into 1 is equal to 1 into determinant 1 minus sin theta into sin theta is plus sin square theta. Now, minus 1 raised to 1 plus 2 is equal to minus 1 into sin theta is minus sin theta into determinant minus sin theta into 1 is minus sin theta minus 1 into sin theta is equal to plus 1. So, for the second term we have minus sin theta into minus sin theta plus sin theta. Now, third term minus 1 raised to 1 plus 3 into 1 is equal to plus 1 into bracket minus sin theta into minus sin theta is plus sin square theta minus 1 into plus 1 is equal to minus 1 minus 1 is equal to plus 1. We have got the expression 1 into bracket 1 plus sin square theta minus sin theta into bracket minus sin theta plus 1 into bracket sin square theta plus 1. Now, 1 into 1 plus sin square theta as it is, that is 1 plus sin square theta. This minus sin theta and plus sin theta will get cancelled. So, 0 into minus sin theta will give you 0 and plus 1 into sin square theta plus 1 will remain as sin square theta plus 1. So, we have got 2 plus 2 sin square theta. So, value of this determinant delta is equal to 2 plus 2 sin square theta. Now, we know that square of any fraction is always positive. Hence, sin square theta will always be greater than or equal to 0. If we add 1 to both the sides, that is 1 plus sin square theta will be greater than equal to 0 plus 1, that is greater than equal to 1. Hence, we can say that 1 plus sin square theta is greater than or equal to 1. Now, we can multiply both the sides by 2. So, 2 into 1 plus sin square theta is greater than equal to 2. So, what we need to prove is 2 less than equal to delta less than equal to 4. Initial part we have proven, that is delta is greater than or equal to 2. But we also know that maximum value of sin theta is 1. Hence, sin square theta will always be less than or equal to 1, because maximum value of 1 is 1. So, 1 square is always equal to 1. So, whatever is the value of sin square theta, it will be positive, but always less than equal to 1. Hence, 1 plus sin square theta is less than equal to 2, that is we can add 1 on both the sides like previous step. That is 2 into 1 plus sin square theta is less than equal to 4 by multiplicating by 2 on both the sides. Hence, the upper limit of this delta is less than or equal to 4. Hence, we can say that 2 is less than equal to delta is less than equal to 4. Hence, it is proved. Moving to next problem. Find the minors and cofactors of elements of the matrix Aij is equal to 1, 3, minus 2, 4, minus 5, 6, 3, 5 and 2. Now, we need to calculate minors and cofactors of all the elements. Now, this matrix is 3 by 3 matrix. Hence, there are 9 elements. So, we need to calculate 9 minors and 9 cofactors. Now, how to calculate minor? Let us suppose you need to calculate minor of the first element, that is A11. So, in this case it is 1. So, how to calculate minor is we need to remove first row and first column, and whatever are the remaining elements we need to calculate the value of the determinant of the remaining element, and that will be nothing but minor. Hence, minor of A11, that is M11, is equal to minus 5, 6, 5 into 2. Now, minus 5 into 2 is minus 10 and 6 into 5 is 30. So, minus 10 minus 30 is equal to minus 40. And how to calculate cofactor of that element is we need to multiply the minor by minus 1 raised to I plus j. Now, here for first row first element I is equal to 1 and j is also equal to 1. Hence, cofactor of A11 is equal to minus 1 raised to 1 plus 1 into M11, that is minus 1 raised to 2 into minus 40. So, it is minus 40. Now, we will move to next element, minor of the element A12, that is minor of element 3 is equal to, now determinant 4, 6, 3 and 2. So, 4 into 2 is 8 minus 6 into 3 is 18. Hence, 8 minus 18 is equal to minus 10, and cofactor of this A12 is equal to minus 1 raised to 1 plus 2 into M12, that is minus 1 raised to 3 into minus 10 is equal to plus 10. Now, we will calculate minor of the element A13, that is minor of the element minus 2 is equal to determinant 4 minus 5, 3 and 5. 5 into 4 is 20 minus 3 into minus 5 is plus 15. Hence, 20 plus 15 is equal to 35, and cofactor of this A13 is equal to minus 1 raised to 1 plus 3 into M13, that is minus 1 raised to 4 into 35 is equal to 35. Now, we will calculate minor and cofactors for the elements of second row. So, minor of A21, that is minor of 4 is equal to determinant 3 minus 2, 5 and 2. 3 into 2 is 6 minus 5 into minus 2 is equal to 6 plus 10, that is 16, and cofactor of A21 is equal to minus 1 raised to 2 plus 1 into M21, that is minus 1 raised to 3 into 16 is equal to minus 16. Now, next is minor of element A22, that is minor of element minus 5 is equal to determinant 1 minus 2, 3 and 2, that is equal to 1 into 2 is equal to 2 minus 2 into 3, that is plus 6. So, 2 plus 6 is equal to 8, and cofactor of A22 is equal to minus 1 raised to 2 plus 2 into M22, that is minus 1 raised to 4 into 8 is equal to plus 8, and minor of element 2, 3, that is minor of this 6 is equal to determinant 1, 3, 3 and 5, that is 1 into 5 is equal to 5, minus 3 into 3 is equal to minus 9 is equal to minus 4, and cofactor of this is equal to minus 1 raised to 2 plus 3 into M13 is equal to minus 1 raised to 5 into minus 4, that is plus 4. Now, we will calculate minors and cofactors for the element of third row. So, minor of element A31, that is 3, is equal to determinant 3 minus 2 minus 5 and 6. Now, we will calculate minor of the element A31, that is minor of element 3 is equal to determinant 3 minus 2 minus 5 and 6. Now, 6 into 3 is 18, minus 5 into minus 2 is minus 10, hence 18 minus 10 is equal to 8, and cofactor of this element 31 is equal to minus 1 raised to 3 plus 1 into M31, that is minus 1 raised to 4 into plus 8 is equal to plus 8. Now, minor of element A32, that is minor of an element 5 is equal to 1 minus 2, 4 and 6. So, 1 into 6 is equal to 6, minus 2 into 4 is equal to plus 8. 6 plus 8 is equal to 14, and cofactor of this element A32 is equal to minus 1 raised to 3 plus 2 into M32, that is minus 1 raised to 5 into 14 is equal to minus 14, and the last element is A33. So, minor of an element M33, that is minor of an element 2 is equal to determinant 1, 3, 4 and minus 5 is equal to 1 into minus 5 is equal to minus 5, minus 4 into 3 is minus 12, hence minus 5 minus 12 is equal to minus 17, and cofactor of this element A33 is equal to minus 1 raised to 3 plus 3 into M33. So, minus 1 raised to 6 into minus 17, that is minus 17. So, in this way we have calculated minors and cofactors of all the 9 elements. Find the integral value of x if determinant x square x1, 0, 2, 1 and 3, 1, 4 is equal to 28. Now, we will expand this determinant along with second row. Why to expand with second row is because there is an element 0. So, it is easy to expand along with the row or column which contains elements 0 in order to minimize the calculations. So, minus 1 raised to 2 plus 1 into 0 into determinant x 1, 1 and 4. Now, second row second element. So, plus minus 1 raised to 2 plus 2 into determinant x square plus x square 1, 3 and 4 plus second row third element is 1, hence plus minus 1 raised to 2 plus 3 into 1 into determinant x square x 3 and 1 is equal to 28. So, now in this expression we need to multiply by 0. So, we can directly cancel out this part of the expression as in it is equal to 0. Now, minus 1 raised to 2 plus 2 is plus 1, hence 2 into x square into 4 is 4x square minus 3, then minus 1 raised to 2 plus 3 is minus 1, hence minus 1 into bracket x square into 1 is x square minus 3x is equal to 28. Now, we will expand this expression. So, 2 into 4x square is 8x square, 2 into minus 3 is minus 6, minus 1 into x square is minus x square, minus 1 into minus 3x is plus 3x, and we will shift 28 from right hand side to left hand side as minus 28 is equal to 0. So, we have got the expression as 8x square minus 6 minus x square plus 3x minus 28 is equal to 0. So upon simplification we get 7x square plus 3x minus 34 is equal to 0. Now we need to factorize this expression in order to find out integral values of x, that is integer values of x. Now 34 into 7 we can factorize as plus 17 and minus 14. So 7x square plus 17x minus 24x minus 34 is equal to 0. So from first two terms we can just find out x common. So x into bracket 7x plus 17 minus, from these two terms we can find out minus 2 common. So minus 2 into bracket 7x plus 17, hence 7x plus 17 into x minus 2 is equal to 0. Now for 7x plus 17 is equal to 0, we can get the value as x is equal to minus 17 upon 2, and from this second part x minus 2 is equal to 0, we can get the value of x as x is equal to 2. In the question it is being asked that find the integral value of x. Now we know that minus 17 upon 7 is not an integer, so we need to ignore that value and integral value of x will just be 2. Hence final answer of this question is x is equal to 2. So in this video we have seen practice problem on elementary operations of a matrix and introduction to determinants. In upcoming videos we will see few more problems on determinants. Thank you.